do this, I need to recall. So what I want to do, I want to see it, and for that I need to go to my presentation. Okay, now I can see it. And four identical spheres. Identical, we know what it means. It means that after they have been connected, the final charge on each sphere is supposed to be the same, correct?
Yes.
So we've got two situations, before and after, and four spheres, four charges, Q1, Q2, Q3, Q4. Can you see the screen clearly?
Yes, I can.
So my numbers are different from yours, doesn't really matter. And what we know, I can use just the same letter. After they touch each other, the charge is supposed to be the same. So now Q1 plus Q2 plus Q3 plus Q4, that's the initial charge of a system, should be equal to 4 times Q because of this word and because they're metallic. Well, if you need to calculate the resulting charge in microcoulombs, you can just use microcoulombs. For example, if I use my number, it's going to be 6.6 plus 5.8 minus 8.6 minus 3.2, and then divided by 4. That will give you that final charge. Now, because all numbers are random, you may have a negative answer. I have a positive answer. And this question. Yes, go ahead.
I think what I did, because I had the same steps, but I neglected to put the charge down, so that's probably why I got it wrong.
Well, you have to just check your calculation.
Yeah.
If your charge turned to be negative, you need to enter a negative number.
Mm-hmm.
And now, in this problem, the second question is different from my question I asked in a lecture. I asked the question, how many electrons traveled? This is a different question. This is how many extra electrons or missing electrons we have on each sphere. So if you have that sphere, number 1 or number 4 doesn't matter because the final charge is the same. This charge has magnitude equal to that number of extra electrons or missing electrons times the elementary charge. So if you're looking for this number, you just need to divide the magnitude of your charge over the magnitude of the elementary charge. And what is elementary charge equal to? That's a standard fixed constant, so you should
Yes, I just forgot what it was.
either know it or look it up on the equation sheet. It's supposed to be there.
1.6 times 10 to the negative 19.
Exactly. So, but if you do this calculation here, you cannot use microcoulombs anymore. You have to use coulombs and coulombs.
So then it would be to the negative 9, sorry, negative 10?
Well, if my answer is 0.15 microcoulombs, that means 0.15 times 10 to the negative, what should I write for the micro?
Negative 9?
No, negative 6
Oh, okay, sorry.
coulombs. And your number, well, my number would be 0.15 times 10 to the negative 6 divided by 1.6 times 10 to the negative 19th. That's supposed to be this answer. You can check it. It's going to be this.
Okay.
The next part is those electrons are missing, absent, or extra. Oh, that depends on your final charge. If your charge is positive, that means this sphere is missing electrons. Electrons are absent. But if that final charge is negative, that means it has extra electrons. So electrons are in excess.
That part makes sense. So then I think the issue is that I just, I forgot the negative and then I did not divide it by the constant. So that was an issue.
Well, you should do it right and see if your numbers work now. Well, unless you have it, next question, if you have a.
Well, that was actually it for now, because everything else I understood from the lecture for the most part. This is the one that just covered.
All right. Okay,
Thank you.
sure, you're welcome. Who's next? Yes,
Yeah, the only question actually, and I just got it right. So
okay,
this is, yeah, thank you very much.
you're welcome. Bye.